you'll spend a lot of your time working in and around a boiler. As part of your job, you need to know how to inspect the water side, which is the inside surfaces of the boiler component that contains water or steam. You must understand what problems to look for so that you can spot possible danger signs. What we're going to talk about is how to search for problems on the water side, what these problems look like, and what can be done about them. We'll be looking at some waterside components that are big enough to get inside to inspect and others that are smaller. All boilers are different, and each may have its own particular problems that require extra attention. However, the kinds of problems we'll be talking about are fairly typical. We'll begin with a component that's big enough to crawl inside to inspect, and that would be a drum in a drum-type boiler or a moisture separator in a once-through type boiler. Well, let's get started. There are three general problems that usually affect the insides of a drum or moisture separator, both of which are waterside components: erosion, corrosion, and cracks. Each of these problems affects metal surface conditions. Erosion in drums and moisture separators is the wearing away of metal, and it occurs when water or steam flows against the metal. Erosion takes place the fastest where the fluid flow is most rapid, in areas where water or steam enters or leaves. Erosion is a mechanical action, while corrosion is a chemical action on the inside surfaces of drums and moisture separators. Corrosion in drums or moisture separators is sometimes caused by oxygen that gets inside the boiler during normal operation. The result is pits or scabs on the metal surface. Corrosion usually results in discoloration and roughness of the metal surface. The most common type is rust. Rust often shows up as a thin layer of red, brown, or black powder on the inside surface. However, any unusual discoloration may be a sign of corrosion. Severe corrosion can change the shape of the metal surface by eating it away. Cracking is the third general problem in waterside components. Even the smallest cracks can lead to big troubles. Here again, you see a cross-section of a drum with a small crack. If the crack goes undetected and uncorrected, it can eventually go all the way through the drum. In a once-through boiler, the same thing can happen in the moisture separator. Now, welds in a moisture separator or drum can also be affected by erosion, corrosion, and cracking. Erosion and corrosion can attack the weld metal just like they attack the metal in the rest of the vessel. Cracks are likely to start at or near the welds. Whenever you check for these problems on the water side, remember that safety is an important part of your inspection. Before you go inside a drum or moisture separator, make sure that there's adequate ventilation. The air should be tested to make sure that there's enough oxygen and to see if there are any poisonous or explosive gases present. If there isn't a noticeable draft through the manways, you should set up a blower. If you can't get good ventilation, or if harmful gas is present, do not enter that boiler. Even if it's safe to go inside, be sure there's an observer at the entrance. An observer must be at the entrance whenever anyone enters the component. In an emergency, the observer sends for help. A self-contained breathing apparatus should be available and located just outside the boiler in case there's an emergency. Even under normal conditions, though, there's something the observer must do. Make sure that everyone who goes inside the vessel comes out before the boiler is closed up. Besides people, waterside inspection requires tools. The tools you need are the same as those used in fireside inspection: a flashlight, an inspection mirror, a knife or scribe tool, and a wire brush. Several containers or envelopes will also come in handy. These can be used to hold samples of deposits that might be found. Later, these samples can be analyzed to determine their nature and their cause. Now, once you have your tools, you're ready to go inside the vessel for inspection. When you enter, the inside surfaces should be as dry as possible. If the surfaces you're looking at are wet, it's harder to see them clearly. Also, a wet vessel is slippery and can be dangerous. Keep track of the tools you bring into the drum or moisture separator. Make sure that none are left inside after your inspection. Left inside, a tool could cause damage to the boiler by blocking the water flow in a tube. In some plants, in order to keep track of the tools, the observer outside the vessel takes an inventory to account for everything and everyone going in and out of the boiler. Another way to make sure no tools are left inside is to tie them to yourself. This also prevents tools from being accidentally dropped down a tube or downcomer, where they'd be very hard to get back. Also, before entering, empty your pockets. Remove any jewelry. This helps prevent accidents and keeps your belongings from being damaged while you're crawling around inside. If you want to smoke or eat, do it before entering, not inside. All of these preparations still may not be enough for a thorough inspection. The inspection mirror allows you to see some hard-to-get-to places in the boiler, but there will be places where even your mirror won't help. And in these places, you can use a borescope, which is an instrument that uses fiber optics. A fiber optic is a glass fiber that lets you see around tube bends and into other tight places you could not normally see. A camera might also be needed. It's always a good idea to take pictures of any unusual conditions found during a waterside boiler inspection. Pictures make it easier to explain exactly what looks wrong. They also serve as a permanent record of unusual conditions. Remember that a thorough inspection takes time. When you do a waterside boiler inspection, be alert and don't rush. You don't want to miss something important. You know, your boiler isn't inspected every week, so a small problem can get a lot bigger before the next scheduled inspection. We've said that corrosion, erosion, and cracks are things to look for during a waterside boiler inspection, and that the tools you'll use are the same as those used in a fireside inspection. Well, there's a lot more to a waterside inspection, and we'll cover some more material after you take a few minutes to read through your text and clear up any problems or questions you might have. Let's continue our discussion of waterside inspection. One problem you'll be looking for during waterside inspection is deposits. There are three types of deposits we'll go over now: sludge, scale, and oil. All three can coat the inside of boiler tubes and prevent proper cooling. And this leads to boiler tube failure. Sludge is a product of impurities in the boiler water. Sometimes impurities enter the boiler with a feed water. Feed water is water pumped into the boiler to be heated. Other impurities adding to sludge are corrosion products and eroded material. In some cases, feed water treatment chemicals can also add to sludge. If you find sludge during inspection, take a sample. Later, the sample should be analyzed to determine its makeup and to help locate other boiler problems. Scale is a hard, flaky material. It's most likely to form in those boiler tubes that get the most heat. Scale that has flaked off the tubes can wind up in the drum or moisture separator, so look for it while you're making your inspection. Take samples of any that you find. If scale has formed on the walls of the vessel, scrape some off and put it in an envelope or container for a sample. The water side of a working boiler is never completely free of deposits. Even with properly treated boiler water, a thin, shiny, brownish-black finish appears on all the wet surfaces. This is a protective finish, and it is normal. Surfaces exposed to water vapor, like the upper part of the steam drum, develop a soft, satin black finish. Also protective and normal. What these coatings do is protect the surfaces from corrosion. The final deposit to look for is oil. Oil is a contaminant, and there shouldn't be any on the water side of the boiler. Sometimes it gets mixed in with the water being fed to the boiler. When this feed water enters the boiler, the oil goes in with it. If you find oil on the water side, find out where it is coming from and stop it. Any oil in the boiler must be removed before the boiler is returned to service. Putting a boiler back in service when oil contamination is present can cause major damage to the boiler. The contaminated oil will form a coating on the inside of the boiler that'll cause overheating of the boiler metal. To find oil contamination, run a piece of paper along the component's internal surface. Now, hold the paper up to a light and look for any oil stains. Oil stains will make the paper clear enough to see the light. Now, water alone won't do this. Another sign of oil contamination is a black ring on the inside of the drum or moisture separator. During the boiler's normal operation, there is water in the drum or moisture separator. If that water has oil in it, it'll leave a ring like a bathtub ring. Fuel oil contamination usually leaves a thick tar-like ring. On the other hand, turbine lube oil contamination leaves a thin, oily ring with fine particles in it. Both indicate oil contamination. In addition to looking for sludge, scale, and oil deposits, internal features and parts of the drum or moisture separator must be checked as part of your waterside inspection. You should already know that drums will be found in drum-type boilers and moisture separators will be found in once-through type boilers. Regardless of the type of boiler, no two boiler manufacturers build their equipment exactly alike. The particular parts and features of one boiler might be different from those of another boiler. For the specific details on the water side of your boiler, refer to the boiler manufacturer's manual. Now, some specific things to check during a waterside inspection are the overall condition of the drum or moisture separator and some of their internal features. Those include the steam separators, nozzle openings, tube and downcomer openings, distributors, and manways. The first internal feature of the drum we'll discuss is separators. Separators, whether they're called steam separators, moisture separators, or cyclone separators, have one purpose: to remove moisture from the steam. All separators force steam flow to constantly change direction. And with each change of flow direction, moisture carried by the steam is thrown against baffles or against the sides of the separator. That is where moisture collects. The dry steam then goes on to the superheaters for further heating. Separators are built in either of two basic ways. One type has baffles for directing the flow of steam. Another type is built to cause the steam to swirl. The baffle separator pictured here causes steam to change direction. As steam goes through the separator, moisture is collected on the baffles. In a cyclone-type separator, steam swirls around inside the separator, and moisture carried by the steam is thrown to the sides. It flows down the sides and collects at the bottom. The dry steam leaves through the top of the separator. This is the cyclone separator in a steam drum. Some drums have a combination of baffle type and cyclone type separators. Moisture separators in once-through boilers are built something like a cyclone separator. However, they may also have screens and baffles to dry the steam. To work properly, steam and moisture separators must be assembled correctly. Check the assembly during your waterside inspection. Since the operator can do nothing to affect the steam separation process, good maintenance of these components is the only way to ensure proper boiler operation. Also, make sure that the screens and baffles affecting flow are in place. Look for holes or cracks in any of the separator parts and make sure that attachment bolts are tight. Cyclone separators should be checked to see that they are positioned so steam flow will enter correctly. All parts should be held securely in place. There should be no broken studs or supports. Loose parts can bang around on the inside of a boiler and cause damage. Nozzles are found in all boilers. They're short pieces of pipe welded to a drum or header. This is a nozzle on the inside of a drum. Nozzles penetrate the walls of the waterside components and connect to boiler instruments on the outside. Nozzles also connect the drum or header to vents, drains, and safety valves, and those connections must be checked for damage. Nozzles must not be plugged with sludge or scale. Pay attention to nozzles that would be underwater during normal operation. These are most likely to become plugged. Also check the welds that attach the nozzle to the vessel. The welds could have cracks, as well as evidence of corrosion or erosion. In drum-type boilers, inspect the places where the downcomers are attached to the drum. Attachments should be checked for cracks, evidence of corrosion or erosion. Downcomers, which are pipes that carry water from the drum to the bottom of the furnace, generally have some kind of baffles at the top, called anti-swirl or anti-vortex baffles. These prevent water from swirling as it enters the downcomer. Downcomer baffles are built in 3 different ways. They may be crossed metal plates secured just inside the downcomers. They may be flat metal plates across the downcomer opening, or they may be a sleeve that extends the downcomer into the drum. In all 3 types, make sure the baffles are firmly attached and that the plates or sleeves are not cracked. In a drum-type boiler, there are hundreds of tubes connected to the drum. Each attachment should be inspected for corrosion, cracks, and erosion. Be sure to look as far into the tubes as possible, since problems are not limited to the ends of the tubes. Check for pitting and scabs on the inside of the tubes. Distributors are another internal feature that must be inspected. Distributors are pipes with holes in them that run along the length of the drum. A steam drum usually has 3 of these pipes: the feed water distributor, the chemical feed distributor, and the surface or continuous blowdown line. All 3 are located below the normal water level. While they look about the same, their sizes vary. The feed water distributor spreads out feed water flow coming into the drum. The chemical feed distributor distributes chemicals along the length of the drum. The surface or continuous blowdown line removes water and solids from the drum. When inspecting all 3 types of distributors, you must make sure that they're supported firmly and that none are broken like this one. Check the holes in the distributors for blockage and erosion. Examine the places where pipes pass through the wall of the drum. Look for cracked welds, evidence of erosion or corrosion, and bending of the distributor pipe. Manways are also inspected closely. Here, be sure to look carefully at the sealed surfaces on the manway plates and vessel. To do this correctly, before inspecting, clean the surfaces with a wire brush. Also, look for gouges and nicks or cracks in the sealed surfaces. Well, so far we've been referring to a drum-type boiler. A once-through type boiler has some specific problems besides the ones common to both boilers. A once-through boiler has no drum, but it does have a moisture separator. The moisture separator of a once-through boiler has 3 large pipes attached to it: the wet steam inlet, the dry steam outlet, and the water outlet. All 3 should be inspected for cracking and evidence of corrosion or erosion. Well, that wraps up our discussion of what to check for in drums and moisture separators, deposits in the drum and problems with steam separators, nozzle openings, downcomer and tube openings, distributors, and manways. Become familiar with these areas and their potential problems. Know what to look for in each during a waterside inspection. Take some time now to review this material in your texts before we continue. A waterside inspection does not end at the drum or moisture separators. Headers and tubes also have to be inspected. Headers and tubes are subject to 5 general problems: erosion, corrosion, deposits, cracks, and problems with welds. Now, erosion is a bigger problem with tubes and headers than it is for the larger vessels, because here the speed of the water or steam flow is greater. When this high velocity flow enters a header, it must make a turn, and this forces it against the header wall. Over a long period of time, this causes erosion. Tube erosion may be hard to find by a visual inspection if the tube is worn down evenly. You're more likely to find erosion by using an ultrasonic thickness measurement device. Erosion may also be found inside the headers. Eroded headers may have gouges on their inner surfaces. This gouging may occur on the header surface opposite the places where tubes are attached to the headers. Now, corrosion can also be a problem on the inner surfaces. It's identified by a discoloration and roughening of the metal. The third problem affecting headers and tubes is deposits. 3 kinds of deposits found in the headers and tubes are scale, sludge, and oil. Scale is most likely to form in these tubes closest to the furnace fire. Here, it is the most harmful and the hardest to detect. Whenever a tube has split open, check both the inside and the outside of the tube before fixing it. This is important in determining why the tube failed. To inspect the inside of a failed tube, look through the hole caused by the rupture. If you can get to the inside surface of the tube, soft scale will be easy to see. It can be removed with a wire brush. Now, sometimes scale is too hard to be removed with a wire brush, or it may be almost the same color as the tube metal and hard to see. To find this type of scale requires very close inspection. Sludge, on the other hand, is a normally soft deposit and rarely sticks to tube or header surfaces. Sludge deposits are heavier than water and tend to accumulate in the tube ends and in the lower drums and headers. If they stay there for a long time, they may get baked onto the inner surfaces. Baked-on sludge can be a major cause of tube failure. Look for discoloration of the tube to find baked-on sludge. Oil can also discolor a metal surface by leaving black deposits there. If no discoloration is seen, make a second check by rubbing a piece of paper on the metal surface. Now, this is the same procedure we used earlier when we talked about the drum and moisture separator. Hold the paper up to the light. The paper will be stained if any oil is present in the tube or header. Cracks in metal surfaces are a problem throughout the boiler. Now, this is a cross-section of a cracked tube. Like all cracks, this one can lead to tube failure if not corrected. Surfaces may crack because of chemical, mechanical, or other reasons. They may start on the outside of the tubes and headers and work their way inward. They can also occur on the inside of the components. Cracks often start in or near construction welds or places that have been repaired by welding. Both kinds of welds should be inspected for erosion and corrosion as well as cracks. You can't see every weld in the headers and tubes by looking into the headers. The tubes are too long for you to see inside surface details beyond the first few feet, if the tube is accessible at all. Usually the end of the tube won't be accessible. Tube access is limited by the amount of handholds in the header where the tubes are attached. Handholds are small header openings intended to provide access for inspection. Now, handhole plates cover the handhole openings. Only headers with gasketed handhole plates are easily accessible. Now, some handhole plates are welded to the header and are usually very hard to remove. These difficulties normally prevent examination of most of the waterside surface and make it doubly important for you to examine the available portions of the waterside very closely. You can't afford to overlook any potential problem. Because of access problems, the borescope becomes an important inspection tool. We already mentioned that a borescope is an instrument that uses glass fibers called fiber optics to allow you to see around corners. Well, this lets you examine header and tube areas that you normally can't reach. For example, if a header has no handholds, or if the handholds are welded in place, you may still be able to inspect the header and some of the tubes. You can do this by taking apart a valve that is close to the header and then running a fiber optic through the valve and pipe into the header. A fiber optic is only one tool you'll use when checking tubes and headers. Other tools you need are a flashlight, an inspection mirror, a knife or scribe tool, and a wire brush. You should also have several envelopes with you for taking samples of the deposits. In short, you need the same tools you used when inspecting the larger vessels. Avoid dropping tools in the headers and tubes. They can be very difficult and expensive to get out. Also remember that the boiler should be as dry as possible when you inspect it. It's harder to see problems on metal surfaces when they're wet. Now, sometimes scale, sludge, or oil deposits require inspection that cannot be done with your regular tools. Tube sampling is one such procedure, and it is done only when there is no other way to determine whether or not a suspected problem actually exists. Tube sampling usually involves cutting a section of a tube out of the boiler and then analyzing the sample. Tube sampling enables you to check problems in places that are inaccessible. Now that we've gone over access problems with headers and tubes, let's cover the features you'll see when you inspect them. There are 4 features of headers or tubes that should be checked during inspection: the handhole plates, orifice plates in the tubes, tube attachments, and any other piping attachments other than tubes. Handhole sealing surfaces should be examined for surface irregularities. Irregularities can be caused by steam erosion, which is the result of leakage. The handhole sealing surfaces should be thoroughly cleaned before you inspect them so that you can see the surfaces clearly. Be sure to look at both the sealing surfaces on the header as well as the sealing surfaces on the handhole plate. Also, check the handhole plate for warping. Now, warping might cause leaks. Look for cracks in the handhole plate. They're most likely to start on the inside edge of the sealing surface. And make sure that the threads that hold the handhole plate in position are in good shape. Orifice plates are located inside some tubes. They are round plates with holes in them. These holes are just the right size to balance the water flow through the boiler. Not all boilers have orifice plates in the tubes. However, orifice plates are important to boilers that have them because they help all tubes get the right amount of cooling flow. To work properly, all orifice plates must be present and their holes must be clear. Measure some of the holes to make sure that they're the right size. Your boiler manual will tell you what size the holes should be. Check all places inside the header where tubes are attached. Look for evidence of erosion, cracking, and corrosion. Also, check the piping attachments. The kind of piping you'll see is vents, drains, and safety valve connections. This piping is attached to the header by welds. Examine these welds closely. Also, make sure that all of the attached lines are clear. Well, we've covered general and specific problems in waterside inspection of headers and tubes. The general problems are erosion, corrosion, deposits of scale, sludge, or oil, cracks, and problems with welds. Specific problems include difficulties with the internal features of headers and tubes. These internal features are handhole plates, orifice plates in the tubes, tube attachments, and piping attachments. I'll take a few minutes now to review these problems and the methods used for detecting them. Once the waterside is inspected, you may be told that it needs a cleaning. Waterside cleaning is sometimes done as a part of a regular boiler inspection. It's done with chemicals that dissolve deposits on the inside of the boiler. During this chemical cleaning process, chemicals are introduced to the boiler. The chemicals dissolve deposits and scale and carry them out of the boiler. This process is not as simple as it sounds. It's a very involved procedure, requiring a lot of time, equipment, and manpower. Also, if the chemicals are used incorrectly, they will attack boiler metal, and this can cause more problems than the cleaning solves. So for this reason, a chemist will regularly take samples of the chemicals in the boiler to make sure that they're not causing damage. Chemical cleanings require some extra work. For example, additional piping is usually needed in and around the boiler. Don't just use any kind of piping. Use a type that won't be destroyed by the cleaning chemicals. It's a good idea to make these extra piping connections far in advance of the cleaning so that any problems that might occur can be corrected. This piping is usually disconnected after the cleaning, so it'll not interfere with normal boiler operation. This special piping carries cleaning chemicals that can be hazardous and must be used correctly. There are several safety precautions you can take to make the cleaning operation a safe one. When involved in a chemical cleaning, wear the proper protective clothing. What you wear depends on what you'll be doing, but generally you will need eye protection and gloves. A self-contained breathing apparatus may also be needed. Eye protection is important because of the possibility of the chemical solution splashing into your eyes. Most chemical cleaning solutions have acid in them that can cause irritation. Whenever acid is being used, clean water should be nearby so you can wash your eyes or skin in case of an accident. Some chemical solutions give off ammonia vapor. If you work with these kinds, you should use filter masks and eye protection. Filters like this will remove the ammonia vapor from the air and let you breathe safely. If strong ammonia vapors are inhaled, hospital treatment may be required. A self-contained breathing apparatus like a Scott Air Pack is used where ammonia vapor or other fumes are too strong to be removed by a filter. Strong fumes could be found inside boiler areas with bad ventilation. Protective outer clothing should be worn anywhere there's a chance of being splashed by the chemical solution. A rain suit and gloves will protect your skin and work clothes from coming in contact with the chemical. During or soon after a chemical cleaning, it may be necessary to go inside a confined area in the boiler. A gas detector should be used to test the air inside confined areas in order to verify whether it's safe to enter them. Make sure gas detectors are available and working before you start cleaning. Another safety precaution for a chemical cleaning is making provisions for containing leaking chemicals. Of course, you always hope that all the piping will remain tight and leak-free throughout the cleaning. Unfortunately, this doesn't always happen. You can expect leaks in both the piping and the boiler. Any chemical solution that leaks must receive special treatment. Chemicals can't be discharged from the plant through the normal drainage systems, so plans must be made to keep them out. One method is to place sand around the bottom of the boiler to keep any chemical solution spills away from the normal drainage system. With small leaks, containers can be placed under them to catch the chemical. You may also have to plug some floor drains to prevent chemical discharge. All provisions for containing chemical leaks must be made before cleaning starts. Now, you may be asked to install corrosion coupons in the boiler before cleaning takes place. These metal pieces are like boiler metal. When placed in the waterside, they are exposed to the chemical during cleaning. Then, once the cleaning is over, they are removed and checked to see if the cleaning chemicals have corroded the boiler metal. Corrosion coupons should be placed where they will get the same exposure to the chemical solution as the boiler. If the waterside is going to be filled to a certain level with chemical solution, place the corrosion coupons below that level. Also, make sure that the corrosion coupons are firmly attached. You don't want them coming loose during cleaning. The final cleaning preparation is isolating the boiler. The boiler must be isolated from the rest of your plant by closing connecting valves so that the cleaning chemical doesn't enter components that are not supposed to be cleaned. All boiler instruments should be isolated because the cleaning chemical can ruin them. Also, it may be necessary to fill the superheaters with water to protect them from corrosive vapors. All preparations should be completed before the cleaning starts. Once the cleaning has started, watch for leaks from the boiler and cleaning piping. All leaks should be marked for later repair. If your preparations for containing leaks were good, you should be able to deal with any leaks that show up. Still, the sooner you find them, the easier they'll be to fix. The exact cleaning process will depend on the kind of deposits in your boiler, the chemicals used, and the way your boiler is built. That makes it impossible to tell you all the details. You have to get those from your supervisor. Whatever cleaning method is used, you still have to get rid of the chemical solution. And there's several ways of doing this. One way this can be done is by draining it all into a tank where it is contained until it can be neutralized and disposed of properly. Whichever way the chemical solution is disposed of, you can't just dump it. It requires special handling. Your major concern will be containing leaks. If possible, collect the chemical leakage so it can be dumped in the same way as the chemical drained from the boiler. After the chemical is removed, the boiler is thoroughly rinsed, opened, and dried. Poor rinsing will leave chemicals that can corrode the boiler. Sometimes a drum-type boiler is boiled out with a neutralizing agent to make sure all the chemical has been removed. To be sure that the boiler has been properly rinsed, inspect it. There are several special aspects of this inspection to keep in mind. First is safety. Before entering the boiler, be sure to test the air inside for harmful vapor or gas. If necessary, wear protective gear to prevent contact with chemicals. Next, remove the corrosion coupons during the post-cleaning inspection and turn them in for evaluation. You might also be asked to take a tube sample after the cleaning. This tube sample can be compared to the tube sample taken before the cleaning. The comparison will show whether the cleaning removed the scale or deposits the way it should have. Be particularly alert for sludge deposits during this inspection. The cleaning process can create large amounts of sludge that may not be completely removed by rinsing the boiler. Sludge is most likely to collect in the lower headers in the boiler. Sludge found in the boiler after chemical cleaning must be removed. It can be removed manually or by repeated flushing. Whatever method you use, the boiler must be free of sludge before it is returned to normal operation. Two more maintenance operations that must be done after chemical cleaning are leak repair and replacement of gaskets. Any leaks that appeared during the cleaning must be repaired. If leaks are found in the tubes, you may have to re-rig your scaffolding to reach them. Usually a hydrostatic test or air test will be done to make sure the boiler has no leaks. These methods of leak detection are covered in your text. The other maintenance operation that must be done is gasket replacement. Gaskets are used to seal some handhole plates and manways in the boiler. Gaskets that have been exposed to the cleaning solution absorb some of it. The solution will eat away some of the gasket, which will eventually lead to leaks. Gaskets exposed to chemical cleaning solution should be replaced. And keep safety in mind at all times. After a cleaning, be especially alert for the presence of chemicals and their fumes when working inside the boiler. Well, during this discussion of chemical cleaning, we've covered safety preparations, disposal of the cleaning solution, and the inspection and maintenance of the boiler that'll be required after cleaning is finished. We've also mentioned the hydrostatic and air tests for leaks, both of which are explained in your text. Let's take time now to read over all of the material before we continue. We've now talked about cleaning the water side of the boiler. The last thing left to discuss here is cleaning the boiler's fireside. The fireside is the surfaces in the boiler that are exposed to fire or hot gas. Fireside cleaning is more common than waterside cleaning, and each plant has its own cleaning schedule. Fireside cleaning is one of the last operations done during a boiler inspection shutdown because water is used to clean the fireside, and this means that the outside of the tubes will be wet when the cleaning is over. The tubes must be dried off as fast as possible to prevent corrosion. And since the fastest way to dry the tubes is to fire the boiler, fireside cleaning is usually done just before the boiler startup. And the purpose of fireside cleaning is to completely remove ash accumulations from the inside of the boiler. This is done by running water over the tubes to carry away all accumulated ash. Sometimes ash deposits are too hard to wash away by simple flushing. If slag and clinkers have collected in the boiler, or if hard scale has formed on the outside of the tubes, these deposits can be removed only by high-pressure water washing. Now, usually the equipment needed to get this kind of water pressure is rented from a specialty company. Such companies provide experienced people to operate the equipment, but their equipment operators will probably need help rigging their equipment and getting it in and out of the boiler, and this is where you come in. Once fireside cleaning is finished, the boiler must be closed up. Before you close each door, check inside again to make sure that no one is left inside the boiler. You can never be too careful about that. Also, make sure that all equipment has been removed. All doors that were opened before you started the boiler inspection and cleaning must be closed. A door that is left open will let hot gases out of the boiler, and this might start a fire. Close and seal the access doors in the ash hopper area. Doors below the water level must be sealed so they'll hold water. Inspection doors with gaskets should be shut carefully to avoid damage to the gaskets. This is true throughout the boiler. Close the doors in the air ducts. If the doors were open to provide access to the water walls, they must be closed and sealed. Air ducts must be airtight in order to work correctly. The boiler is not completely closed until you shut the openings in the drums and headers. In a once-through type boiler, you must close the manway openings in the moisture separator. Before closing manways and handholds in any boiler, remove all tools and equipment from the water side. No loose pieces should remain inside. Double check all internal parts for tightness, especially those that needed recent work. Just before closing the manways, make a final inspection of the inside. This is to be positive that you are not trapping anybody inside that boiler. To close the manways and handholds, install a new gasket on each cover. Position each cover so it's centered in the handhold plate or manway opening. Hand tighten the nuts that hold the covers in place. You have now closed the water side, but you're still not ready to fire the boiler. The boiler was tagged out at the beginning of the inspection. Tagging is the administrative procedure used to shut down the boiler. Tagging out assured that none of the boiler's valves or controls were tampered with during the inspection. Once the boiler is closed up, all of the work is complete, and the boiler is ready for startup. Someone with authority must decide to remove the tags. Also, you should check the safety valves to make sure they are not gagged. The safety valves are sometimes gagged when performing a hydrostatic test. It's very important that these gags be removed before the equipment's put back in service. We talked about gagging earlier in the section, and it was in your text when we talked about hydrostatic testing. Now, there's still one more procedure that must be finished before the boiler is pressurized, making sure that the handhold plates and manways don't leak. Now remember that just a few minutes ago, we installed gaskets on the manways and handhold covers. Manways and some handholds are sealed with a gasket made of steel and asbestos, like a flexitalic gasket. This gasket is compressed when it's in service and becomes a very tight seal. Since these gaskets are compressed so tightly, they can't be used after the manway has been opened. This is why you need new gaskets to close the manways. Now, we're ready to pressurize the boiler. Increase the pressure slowly by using your plant's condensate booster, or feed water pump. Which one you use will depend on your individual plant. When the pressure reaches about 20 pounds per square inch, or 138 kilopascals, check the manways for leakage. If there is leaking, check to see that the nuts are hand tight. Then, tap the manway cover with a hammer. This will reposition the cover and should even out the pressure on the gasket, stopping the leakage. By now, the pressure should be starting to compress the manway gaskets. Leave the manway nuts hand tight. Let the boiler do some work for you. Inside boiler pressure will compress the gasket more evenly and make a tighter seal. In order for handhold gaskets to seal properly, the boiler pressure must be higher than 20 pounds per square inch. So, take the boiler pressure up to about 50 pounds per square inch, or 345 kilopascals. At this pressure, the boiler will compress the handhold cover gaskets the way it compressed the manway gaskets. Check for leakage. If necessary, tap the handhold cover with a hammer to reposition them, stop the leakage. When all leakage is stopped, tighten the cover nuts. Now, the boiler is ready to be fully pressurized. While the boiler is being pressurized, take note of where leaks are located so you can repair them later. Boiler leaks are easy to spot while the boiler is being pressurized because water or water vapor forms around each leak. Check the manways and handholds again after the boiler has been fully pressurized. Be cautious when checking the covers for leaks at operating pressure. Steam is invisible. When you see steam, what you're really seeing are tiny droplets of water that look like a white vapor. These are droplets that have condensed from the steam. However, if the boiler temperature is high enough, condensation won't take place until the steam is far away from the actual leak. If high temperature steam is leaking past the seal, you won't see it. To avoid burning yourself when making these inspections, check the covers with a rag attached to the end of a stick. A steam leak will make the rag move around. Don't get too close to the covers until you know exactly what you need to do and where to do it. Another way to find a steam leak is to listen for it. There's a loud, high-pitched rushing noise associated with this kind of leak. Always listen for leaks when working around a pressurized boiler. Remember, each plant runs a bit differently. Always check your own plant's boiler manufacturer's manual and the safety manual. This completes our talk on fireside cleaning, closing the boiler, tag removal, and how to seal the handholds and manway covers. This also ends our entire discussion of boiler inspection and cleaning. We've covered a lot, so take some time now to review your text. Go over all of the material, and make sure you understand it.